Thank you very much. So now it's time to move into our second roundtable of this Beyond Conference Space. This will be titled Nuclear Fusion Technologies for Space Applications, Opportunities for Cross-Sector Collaboration. And this panel will explore the synergies between these two advanced fields. Both nuclear fusion and space operate in some of the most extreme and demanding environments, and that's why they share many common challenges. For instance, today key topics will include robotic and remote maintenance, advanced diagnostics, material erosion, and the use of simulations to improve performance and reliability. Moderating this session is Mr. Carlos Hidalgo, Director of the National Fusion Laboratory at CIEMAT. Carlos has an extensive background in plasma physics, including pioneering research on plasma turbulence and diagnostics, and has worked with leading fusion research institutions across Europe, the US, and Asia. And finally, just a quick note before we dive in. For the ones involved in technology transfer between these sectors, we are very excited to hear from nuclear fusion experts today in a space context. So it will be interesting to see how closely related these fields are and that they are not as far apart as one might think. With further ado, please, the floor is yours and welcome.
Microphone is on? Now the microphone is on. So thank you very much for the introduction. I think you're completely right. Nuclear fusion and space are extremely far fields. And I think this makes maybe this panel discussion unique and very interesting. Actually, this is an area where we talk about knowledge transfer, quite unknown territory, that maybe everybody talks about the importance of transfer, but not so many people put emphasis. So I think we should congratulate the organizers to look into this cross-field fertilization between two great challenges for humanity, fusion energy, and space applications. Maybe as a first step, I will propose that our panel members make a very short comment about their coordinates, just 30 seconds. We start from my left, Duarte.
Okay, good afternoon. My name is Duarte Borba. I'll give you just a couple of words what I do, what EUROfusion is. So EUROfusion is a consortium that puts together all the laboratories in Europe that work in the field of fusion research. It is funded by the contributions by its members through national funding, but we also have a large part of the funding comes from a grant from the European Commission via the Euratom program. So we have the main mission, of course, is to progress and advance fusion technologies, but we have a very important mission as well, which is as written in the Euratom program, is to make sure that the technologies we develop, the know-how that we acquire by developing fusion can be used also as much as possible in other applications, either in industries, commercialization of projects, and this has been a very good feature of fusion program, but we are promoting this as much as possible, including applications to the other fields of science, including aerospace and space exploration. So I think with this introduction, I'll continue and elaborate more on this.
Okay, thank you, Duarte. It's good to know that we have already European organization that trying to put emphasis in this knowledge transfer. Maybe a few words next, Miguel Ángel.
Yeah, hello, thank you for welcoming us here. So I'm Miguel Carrera, I'm the founder and CEO of AVS. AVS is a company that was founded 18 years ago already. We started off as a company looking for hard problems to solve, and these hard problems were mainly in the fusion, space, and accelerators areas, where they have this common issues like harsh environments, thermal loads, radiation, low maintenance or no maintenance. So we started off developing full subsystems for all these three fields. And right now we are progressing into knowledge transfer between the different fields, both in technology and skills, and migrating into system-level performance. So right now we are delivering full systems in fusion, in accelerators, and space, and doing this cross-talking of technologies.
Thank you, Miguel Ángel. Joan Manel?
Buenas tardes. My name is Joan Manel Casalta. I'm the responsible at SENER of the Science Business Development Department. SENER is a large private engineering group. We are more than 4,000 people. And in the part of the aerospace now we are crossing the number of 1,000 people working in different places in Bilbao, Madrid, also here in Sardañola. In that field we also are focusing our projects, our technology, to have different type of business and mechanisms in communications, in navigation for different fields, especially in space, also defense, but also we are transferring this technology and using this technology for large science infrastructures like telescopes or also fusion market.
Thank you, Joan Manel. Luís?
Hi, so my name is Luís Martín, and I work for a company called Arbeves, which is the technology broker of the space, the European Space Agency here in Spain. And our mission is to transfer technologies from Spain to other sectors and vice versa, but with a very commercial approach. So today here has been announced the PhilLab, which has a much more research and investigation approach. You have the business innovation, the business incubation centers from the ESA as well, focusing on startups. And we are here to enable business to be made, you know. So we are in this very commercial approach to make business between space technologies and other technologies.
Thank you, Luís. Antonin?
Hello everyone, I'm Antonin. I work in Extenso Innovation Croissance in a French company as a FUTA broker, so French broker for the EUROfusion technology transfer program. And so as for you, our objective is to connect some needs that we find in other sectors than fusion with fusion technologies that we collect from researchers, for example, for CMAT or CEA in France.
Thank you. So with this high-level panel, of course, if we want to put two communities that are extremely far and they don't meet, they don't have so many opportunities to discuss their dreams and their challenges, I think the first point is to highlight the importance of a common language. So, and this is the first step to promote collaboration and effective communication. So I'm pretty sure the high-level colleagues in the panel will make the best to use a very easy language to emphasize their views about possible areas of crosstalk between fusion and space opportunities. And the idea is to organize this very short time window in 3 blocks. The first one, we will go into some synergies that we believe might be interesting for the coming years in space science and fusion. Second, we will go into one of the key points, is the human factor. And I see young people in this room, which is very good. So the human factor is the key element for any future in both communities. And then last but not least, of course, funding is a magic word. So we will try to look into these funding opportunities. So we talk about synergies. It was mentioned at the beginning. One area of possibilities is the area of robotics and remote maintenance. And I wonder, Joan Manel, what is your vision in this area?
Okay, let's start by remote handling. To say in easy words, fusion machines needs maintenance and longer operations. To do that, you need to replace big parts, And to replace these big parts, you need large machines, mechanisms, with really good precision somehow. So this is not a usual market where the machines do not request really good precision. So you need to combine large mass with good actuators, precision. So you have different disciplines that if you are in this space market, you can use for this remote handling market. So you have actuators, or you are doing control software, or you are doing mechanisms, or you're doing structures. You can translate, or you can use this expertise in remote handling market for fusion market too. We have good experience on that. So SENER is a company working in space for more than 55 years. So we have been really expert doing mechanisms for a lot of science missions, Earth observation, and also we are in the communication market. So, for example, in one of our markets, mainly for commercial space market, we need to develop our own actuators. So sometimes for space, the actuators are not qualified, so we decided at that time to produce rotatory actuators. And we started to work in remote handling machines, especially for other infrastructures called DONES. We realized that we can use these, for example, these motors in that market. The main be careful. So each market has their own rules, and you need to adapt this to each market. So in that case, our trouble was the radiation. So we need to qualify this motor to radiation, and we use a Spanish budget to do that. CDTI helped to do that, and also the infrastructures of CIEMAT, Nayade, in order to get our motor to put in radiation and qualify this motor in radiation. So we have an opportunity for a business that we already know, to do machines, hexapods, somewhere else, and upgrade with a motor capable to withstand this radiation and use in that market. One last word, and I don't want to spend too much on that, or recommendation, is that, okay, when you're working in a space market, for example, you know the rules from ESA, ECSS, so you need to adapt, or you need that time to adapt to the different market rules. For example, fusion, it's a market that somehow required safety and nuclear knowledge. So you need to qualify on that, and it's not only to get your product and move to one to the other, it's to identify what are your needs on the market and learn about it and be prepared and adapt your product to that market. That's
okay, thank you. I think this looks very attractive, because actually remote maintenance is one of the areas where the future community is having let's say a gap. So this might be an area very interesting for the future. Diagnostics, measure what is measurable and make measurable what is not so. I think it was Galileo. So this is for sure a very fascinating area. And Miguel Ángel, how do you see diagnostics in both fields?
Okay, so as I said before, we try to look at difficult problems to solve. One of those was fusion. One of the fields was fusion, and we managed to put our technology in some of the in-vessel diagnostics for ITER. And right now we are developing some in-depth physics in the CXRS, for example, one of the diagnostics for ITER, and we're doing many of the main diagnostics for ITER. So these diagnostics, I mean, is closing. I don't want to miss a part, but we are closing the loop of the reaction. And in order to close the loop, we have to look at the plasma. And in order to look at the plasma, which is at high temperatures, vacuum, radiation, etc., you need a multiphysics approach in order to be able to develop the engineering side of the diagnostic, in order for it to survive and to do its work. So this multiphysics and this capability of these skills in order to develop an engineering model from the multiphysics approach, that is a lot of conditions put in place in order to define and to design this diagnostic, has given us the skills to develop other things like space thrusters. So 6 years ago, we founded a company in the UK, which is EUROThrusters, which is aiming to develop thrusters based on water as a propellant. And there we have a plasma, that we have to understand what is happening there, and we used these skills in order to define the products that we are trying to promote and to sell. It has been the case also in accelerators. So this multiphysics approach was the key in order for us to be the ones who are developing the hadron therapy accelerator in Spain. So we use these skills that we learned in fusion to develop this ion source, for example. Mm-hmm. So these are the things that we have learned from fusion. Of course, there are more practical things like coatings, like weldings, like quality standards, like radiation standards, and also like system engineering. This is something that is very, very interesting. This is something that is very well thought and very well performed in fusion, and that we are taking from fusion to space and to accelerators.
So I think you describe a scenario where there's great opportunities, not only for the future, but even today. And this is I think, very encouraging for both communities and very fascinating. You mentioned, actually, Miguel Ángel, the area of materials. And I think that here we have an expert from fusion, Duarte, and for sure the field of material science, plasma wall interaction, coatings you mentioned. I think this is a very tricky and crucial area for both areas. So, Duarte, how do you see the field?
Yeah, so I would say this is probably the holy grail of fusion research, is to choose which materials use in our experiments, in our future experiments, eventually in the fusion reactor. We have very extreme conditions. Was already mentioned that the extreme conditions of fusion also some parallels to aerospace and space exploration. Throughout the decades of research and development, fusion research have developed and explored different materials, covering a large number of topics. Early on, we converged on carbon and carbon composites and graphite, so we have really a lot of experience with all these kind of approaches. Nowadays, we have moved on because of issues of fuel retention and chemical properties of carbon was not ideal. So we move on to other materials. Light materials, we explored a lot beryllium. So fusion field is really expert on handling beryllium, but also boron and boron coatings and deposition. And more recently, we moved for the areas of the experiment, we have the highest heat fluxes. We are tending to use metals, in case steels, but mostly nowadays tungsten and tungsten coatings. The studies cover a very broad spectrum of physics and processes. Mostly, the most challenging one, of course, are high heat flux applications, but we cover erosion, sputtering, redeposition, corrosion, and very specifically, but very important to highlight, is the retention of hydrogen. Maybe if I have 1 minute just to see, in my view, what are really the most pending issues that we are developing that could be applied to aerospace and space. We have developed advanced manufacturing techniques, specifically to manufacture plasma-facing components, and the coating techniques, we are very advanced on that. We have advanced cooling strategies, as I said earlier, for high flux heating applications. And we use a lot nowadays advanced tungsten fibers, reinforced tungsten fiber composites, and tungsten coatings. But I will already mentioned, my final point will be on our extreme knowledge on the characterization of the materials before they are installed for validation, verification, but also on the post-experiment analysis. We have a lot of analysis tools, modeling tools. I just say one example that I will finish this is short intervention, is we have ion beam analysis to really characterize the materials almost at the atom level, and the surface where the material is interacting with the plasma.
So thank you, Duarte, because in reality when we talk about revolutions in technology, quite often you have to pay attention to apparently insignificant details. Yeah. And you have listed a number of topics that looks apparently significant details, but in reality they are the key elements to move towards a reality in many of our dreams in fusion and also space applications. You have already mentioned, many of other previous colleagues mentioned that we are in two very far scenarios. Quite often when we are in a very far scenario, this can be an advantage. You want to test models and you want to improve the performance of space application and fusion applications. You want to have fully validated models. So I wonder, Antonin, how do you see these very far scenarios as an advantage to validate models?
Effectively, as you said, it's a main subject in both sectors, and we need to better know the plasma in fusion to have to better control the reaction, and also to not damage the reactor, because the plasma is really hot. And in the space, it's also a subject to control the plasma. So there is synergies that are there is opportunities of synergies with these two sectors. Despite this, we do not have yet a success stories in this kind of testing models in the two sectors, but we do have some that are close to this. For example, the CMAT transferred the technology that developed an algorithm to analyze the turbulences of the plasma to Madrid University. Yes, sorry, for plasma filters. We have also examples of durable coatings for harsh environments, robotics for harsh environments also. And also we dispose of a large portfolio of technologies that are available for transfer to space applications. And in those technologies, we have, for example, the University of Alicante that developed a simulation of microstructural changes induced by radiation that can be really useful in the space application. We have also Muscle 3, that is a really big fusion algorithm that can couple a different algorithm in different languages into a single workflow that will use the different algorithms, so it can be useful in every sector, and the space is part of it. We have also software for the calculation of residual activities in component exposed to radiation that was also developed in the CMAT, and that can be, in my opinion, really useful in the space sectors. And so we do have, as I said, a lot of technologies that are available on the FUTA website. So the FUTA is the name of the tech transfer program of EUROfusion. There is a new website, we have an old one, and there is a new one that is in synergy with Fusion for Energy. We tried to combine the both effort of the technology transfer program of Fusion for Energy and the one of EUROfusion into one website that you can find by going on the EUROfusion or on the Fusion for Energy website. So I encourage everyone that have a needs that can that reach what we are talking to contact me, contact also Kim or the EUROfusion program to find some needs that can match some technologies, that can match your needs.
So thank you very much. I think following all your remarks in 15 minutes, you have covered the universe of possibilities. Of course, to address all these challenges and technologies and open question, we need a human factor. And the human factor is needed everywhere. And I will say we need a new generation of people with interest in science and challenges. And of course, in order to attract the human factor, we need to offer something that is attractive. So I wonder, Luis, how do you see this challenge, getting a new generation into fusion and space?
Okay, so I think we have like space and defense, we have a dual challenge, which is not only the human factor. The human factor, honestly, I think is impossible to solve. If you see a space was 200 billion by 2020, will be the last McKinsey report, almost 4 trillion by 240. So there's no way to print humans. So we won't have, as we are behaving in space today, for example, with in all the space engineering companies, the CEO is a space engineer, which it's okay, but the CFO is a space engineer, the human resource manager is a space engineer. So this has to end, and we will need to reserve the engineers to the tough cases, While in the rest of the cases, we will face a new industry. I think in nuclear, I'm not very fluent in the nuclear part, but I think it's very similar in terms that there's a lot of very tough issues to solve, and then this will enter into mass market, So we work with a lot of space companies, and we say, okay, this era of 5,000 pages to solve a problem as a unique way of approaching that is going to end. And we will need to work, and this is what we do from the broker perspective, is like in the logistics, I think 50 years ago, when you want to send a package from here to Via Laietana, the driver found the best way. Today, maybe it goes to El Prat and make an assembly in there, and then goes to the distribution center because it's much more efficient. So we will need two things. We will need a lot of talent that will always be scarce, I think, in these two areas. We won't have enough people, so we need to reserve the people for the toughest challenges, and then to have a lot of more processes. So I will always say with the companies in space, you will meet with the purchase manager of Mercadona, which is a famous supermarket here, because you won't need, and if you need it, will be somehow bad for normal purchasing things. And for that, and is what we are involved in the broker mechanisms, trying to do things easier. So now, from the broker's perspective, you have a tough issue in space, for example, that the subject domain is only controlled by a few people, and you want to export to another domain where a few people is, so the possibility of making a match is very low, okay? So we want to enter, we say a joke, into an era of brochures, where you can go to a simple concept where a normal human, not a super engineer, super scientist, could understand, digest it, and go like in a normal funnel, sales funnel level, to a place where you have a high interest. You can brief your scientists, I can brief mine, so they won't waste their time for doing that. And this is what we are now involved. Try to make first easy to understand, understand if this is something for me, so different layers of people and getting there. From a very business perspective, and from the business perspective, we need NDAs for the meetings. We need sometimes, we have very small business with very high technology to have like a basic agreement document, something like that they miss to protect their IP. And I'm glad to see here AVS, because they made the transfer inside, because it's much more easy, and that the efficiency of making inside where you have all the knowledge and you don't need to convince anyone is a real proof of how difficult is this. And this is exactly in the challenge where we have. Yes, we have humans, but the humans will be there, won't be humans enough, which is something that Europe has to take care about. Otherwise, China will always win. If we are competing just number of humans against number of humans, they have a communist party that can say this million people will solve the fusion thing, and we cannot do that in Europe. So we need really, and the other thing, we need to help humans with standardized processes. Unless we do standardized processes, the processes become inverted pyramids, when you need more senior people than junior people. If you create standard processes, you can teach and you can nurture the junior people to become very fluent on the other thing. And this is what we do. Yes, humans, we won't have enough humans in Europe, and we need to be very strong on the processes to help those humans and make them much more productive.
Yeah, because following your remarks, because we need not only number of people, but qualified people. I think probably it is the only way it will be to emphasize that we need passion for knowledge, and that this really is worth for a new generation of young scientists, engineers, whatever. I think this is maybe an issue for communication. If we don't have enough staff and competition with other international partners, you mentioned China, I think is a good example. I think that maybe it's our duty in this roundtable to transmit to the young people sitting in this room that we need you. We need people with passion for knowledge. That's what is needed. And maybe, and this is a question for all of you, because here we have people from public institutions and we have people from industries. I wonder whether a cooperation between these two pillars, industry and public bodies, could be useful to make your future. I look at the young people here because that's the guys we need. Whether we should try to explore new scenarios of cooperation between public institutions, industries, even in cross fields where many expertise are common, to emphasize that there are opportunities, because these young people sitting in this room will move into space or into fusion only if they see opportunities. And this is maybe an issue of communication, of what to do in terms of communication. Should we take any action about cooperation between industry and public bodies?
Maybe I propose to take a step backwards before we move forward and explain a little bit more what we are doing, and then we can discuss a little bit more, expand what we should do or we should do more. Obviously, fusion research and space look very far apart. Of course, we have very common challenges, but we're trying to bring all these communities together as much as possible. We have different fora that we use to bring these two communities together with industry and approaching industry as much as possible. I would just like to mention one that I think is very important for us, is Aeroforum, which is an organization that involves the biggest fields of science across Europe, where both EUROfusion and the European Space Agency is a member. So this is a way of bringing people together and they collaborate together with the external parties. One thing that we mentioned earlier, which is also very important for us, is our FUTA program. The FUTA program was set up over 10 years ago, and we used the space model, not by accident. I think there are a lot of synergies and a lot of commonalities between what we do in nuclear fusion and the space industry and the space research. So we used our model we wanted to use, using the ESA model at the time. So we created a network of brokers that mirror their what was implemented in the space industry, and I think it's worked very well. Our present network of brokers have a lot of same people work for both sides of the industries, and this is really being a great success. We brought the entire fusion program into this bandwagon, including ourselves, EUROfusion, but also Fusion for Energy. And your challenge is industry. Maybe I'll leave the floor to others to comment on this.
Any other remark?
Well, to take your words, for me, to be positive, the good news is that we have really very, very good engineers from our universities. So they are there. You're right, maybe it's a question of communication, so we need to be close to them to show what we are doing. When you show them what you're doing, a telescope, a fusion plant, or satellite, they say, okay, it has been doing here in Spain, here in Barcelona, and okay, when they are there, they are convinced. So, sorry, the first point is to convince them not to go to Europe. So it's to retain our people or the university here in our industry, and each country should do the same. And this can be made being closer to university. And the second point you pointed that it's not enough to fool with that. You need a senior engineer, but in another way. So in a pyramid way. So okay, you need a chief engineer. So you talk also about system engineering to help them to learn in that way. But our experience is that the people is getting from the university space. In aerospace, there is aerospace universities here are really, really good and are helping us a lot to make our work.
Mm-hmm. Well, I think this is very important.
Yeah.
So we have the most important
Not
quality.
enough.
We have quality. And I see one more remark, Luis.
Okay, so one thing that I will suggest, and hearing some of the remarks of the previous table, about how to manage the risk, and I think the risk should be managed or should be digested, not managed, by the public institutions. They not digested. They should pay for that, and the private companies should create wealth based on their profit. Running on that, I think it's on a fair profit, But this is a cycle that should be taken, and I think we saw the Draghi report, and we are in a crucial moment where we need intelligent people, but we don't want heroes. People who is sacrificing. You could be a normal guy or normal girl with some talent and have a nice work and work in that without being a hero. I think in Spain we are roughly used to have a lot of heroes. I think most of the people who are sitting here in this table, you are heroes, and this shouldn't be the case. It's there are other geos where you don't need to be a hero, and I think this is the type of environment that you need to. Of course, you need to be talented. You need to be a hard worker, but our big Europe should pay for that new era.
Yeah.
And to host a lot of these young people.
Because time flies, but I think you mentioned something very important. You mentioned the question of risk and how to share the risk between public and private institutions. Maybe a comment for the people, young people. I look into the young people here today. I think that fusion is now in a very in a great revolution and transition in the program, where, following your remarks, Luis, public and private partnership is going to be a key element. So how to share the risk, this is a very relevant question. I could argue, following your remarks, that probably public institutions should take those technologies with very low technical development, which means higher risk. And industries, private sector that looks for profit and is fair, should take the responsibilities of those technologies that are more advanced, higher TRL level, technical readiness level. This may be a way to approach the question of risk. But this risk can only be done if we have a new generation of scientists. So I have to say, because the time is now over, that I have been actually involved in this area of, as you, in the industries, in the area from the public institutions, in the area of transfer of knowledge between both fields, and I have to say that it's worth. You learn a lot talking to a community that have different dreams, and is very, very stimulating. Not only in terms of intellectually, but also very stimulating and profitable for the country and for Europe. And today we have mentioned many times Europe, countries. I will emphasize in this global world that all these challenges can only be addressed if we have an open mind, being not naive, so we need to keep our knowledge in Europe, but we need really to have an open mind, and international collaboration is a key element for the future. And I think that the time is over. I would like to say thanks very much to the all panel's members, and thanks all to you, and I hope that you find passion for knowledge, fusion, space, and cross-talk between both communities. Thank you very much. I think we have jazz and something else waiting for us after the session.
Exactly. Let's give them a warm round of applause. Thank you very much for joining today and for this interesting debate. So now I think it's time to go downstairs in the space yard where we'll find the casual after work. Thank you very much.
Thank you. Thank you.